So this is question number 3 on mock exam A. It's mostly a projectile motion question, and then it goes into some work. So we have two people, Daryl and Peter, who I've modeled as golf YouTubers, and they want to hit a shot so that both of the golf balls collide at point X. And we're given some information. So the first question is really easy. It's fine for you. It's displacement for X. So he's 100 away that way and 60 that way. So displacement is just S. So using the Pythagoras' theorem, I'll just go 60 squared, take the square root of that. We get 116.6 meters to 1 decimal place. Now, show that the balls should collide after 10 over 7 seconds. Now, I include the word should here because it's a part of the question that doesn't actually make too much sense. So, the simplest one is to just check Daryl. Now, his shot is directly horizontally. So, we can use the fact that Sx equals Ux times t. Now, the distance he has to travel is 100 plus 10, which is 110. So 110 equals Ux, which is just U times T. So we might need that later. The SY equation, well, it goes from 70 to 60, so we go minus 10 meters down. Well, the UT, using S equals UT, is nothing, because there's no vertical displacement in its velocity. So that just leaves it with minus 4.9 T squared. So T squared is 100 over 49. So T is 10 over 7 as per. So we didn't actually need this SX1, so that's good. Now, find an expression for tan of alpha. So what we want is that the uh, they have to collide after 10 over 7 seconds. So we can actually write that T is 10 over 7. Now we want tan alpha, so we should probably either find sine or cos. Now the simplest one to find is cos because of Sx equals Uxt. So you can check Sx equals Uxt down here. So Sx we know is 100, is Ux, which we're told is 2U times cos of theta. So 2U cos of theta times 10 over 7. Now, 2 times 10 over 7 is 20 over 7. And then if we times by 7 divided by 20, we get 35. So U cos theta has to be 35. So, actually, another thing we can find is the value of U, which we have up here. So, we know that 110 has to be U times 10 over 7. So that implies that U is 77 meters per second. So we can use that to our advantage. So we get 77, I should say, from that is 35. So cos of theta is 35 over 77. So now, that makes sense. So this is adjacent and hypotenuse, and we want tan, which is opposite and adjacent. So this is 35, that's 77. So this x is just square root of 77 minus 77 squared minus 35 squared. So 77 squared minus 35 squared is 28 root 6. So therefore, I don't know, it's actually tan of alpha and not theta. What am I doing? Is the opposite, which is this. So that's actually 28 root 6 over 35. which actually works really nicely as 4/5 square root of 6. So that's an expression for tan alpha. Now, the model suggests that the balls should collide on impact, should the balls do not actually collide at x. Right. Well, when we have the SY equation for this, for Peter, says that it should be 60 equals, well, we have 2 times 77 times sine. Now, sine is opposite and adjacent, so sine theta, or sine alpha rather, is 28 root 6 all over 77, which again, oh no, they have a factor of 7 in them. So it becomes 4 over 11 square root of 6 times, well, we get 4 over 11 square root of 6. Now, already this is going to be a problem because we have a square root of 6 in here. So it's going to show that because, well, root 6 is irrational, you can't get a rational number out of here with the square root of 6, or should hopefully. Then we have minus 1 half g, which is 4.9 times 10 over 7 squared. Now, 10 over 7, if we square that and times by 4.9, we get 10. So if we add that, we get 70 equals 2 times 77 times 4 root 6 over 11 gives us 137.17 dots. So they're not equal. So therefore, the balls don't collide at x, capital X rather, it should be, since 70 is not 137.17, rather, 13. Okie doke. Now, question B, a particle is in a medium with resistance to motion of px, waiting for p is constant, and x is the about a particle. Mass of 1, initial speed of 120, comes the rest of 2 seconds. So, show by using an infinite sum that the work done by a force W can be written in terms of force function F as W equals the integral of F dx. So, if you have a bunch of different work, or a bunch of different forces acting at different points like this, then this is going to be the first force times the first distance, and then F2, X2, F3, X3. So if each force is closer and closer together, so as Fn, Xn, and then delta Xn approaches 0, this quantity here, Fn, Xn, sum of Fn, Xn, actually tends towards an integral of F times smaller increments of Xn, which becomes a dx. So it's a very passe bit of it, but anything like that should work fine. Identify the units of P. Well, resistance of motion is a force which is kilogram meters per second squared equals the units of P times by the distance, which is in meters. So we cancel the meter units. P is kilograms per second squared. Cool. If the total work done during the deceleration is 240 joules, show that P is 1 over 30. So what we're actually doing is that once it comes to rest, you can think of that coming to rest sort of like a uniform acceleration problem. Although this somewhat does contradict the thing down here. But when it comes to rest, you can sort of approximate it as a linear motion question. So that's what we're going to do first. So it starts at 120, comes to rest after 2 seconds, I think it was. After 2 seconds, and then the distance is what we need because we're integrating with respect to distance. We want to find out second integration value. So we're going to use s equals 1 half u plus vt. So 1 half 120 plus 0 times 2. Those cancel, so we get 120. So then the work done is 240. So therefore 240 is equal to the integral between 0 and 120 of px dx. Now the p comes out and this becomes px squared over 2 uh, between 0 and 120 equals 240. Now, this 0 makes this 0. So what we're actually going to do is just find the value at 120 because x squared over 2 times by that is 0. So it's not actually going to make a difference. So we're going to 120 squared over 2, 7,200. So 120 squared, so that's 7,200 p is 240. So p should be 1 over 30, which indeed it is. QED. Now this bit, I know it sort of contradicts what I said before, as I said. That wasn't really proper English, but whatever. That sometimes it's actually fine to write it as a linear motion first. When it comes to rest, it's probably a key thing. But sometimes the forces can be different. So it's not like one continuous force is slowing it down or anything. So it could be varied forces along the journey, which can affect the model. The only real exception to this is if, well, if it comes to rest. When it comes to rest, it tends to be the only thing that sometimes it's fine to do it with. In this case, it is. I should have wrote like uniformly or something. Yeah, that's the answer to Mock A question 3.